So what do you mean by conservative force, beta? First point in this one. Conservative force is nothing but a path independent path. That means work done is path independent in this one, and it depends only upon the initial and as well as of your final positions. So you can say that work done is path independent. It is a path independent. I can say that it depends only on initial and final positions. Done, beta? Whereas non-conservative, it is a path dependent. So I can say here, work done is path dependent. That means it depends on path, how you are taking it. It depends on your path. Point number 2. Work done is right now started in a form of potential energy. And here, or I can say that it will be stored in the form of potential energy. Whereas in the non-conservative, work done has been lost in the form of your sound, heat, anything. It can be anything basically. Okay. So can I say that work done is stored in the form of potential energy in conservative. Whereas in non-conservative, work done is lost. Work done is lost in the form of heat, sound, etc. The example for the non-conservative forces are electrostatic forces, gravitational forces. All of them are path dependent. They are independent of the path. They depend upon only the initial and as well as of your final. Whereas non-conservative force, the best example is friction, viscous force. That all of them are path dependent. Then beta. So work done is what right now I can say here. It is a path independent and depends only on your initial and as well final portion. Work done is stored in the form of what? Potential energy. Okay. Whereas it is a path dependent, non-conservative. It depends only on your path. Work done is lost in the form of what? Heat and as well as of your sound. Example is friction and viscous force. This example is electrostatics and gravitational force. Done, beta? Next and very important point which you need to remember, that is equilibrium and the nature of equilibrium. Equilibrium and nature of equilibrium. Remember, for equilibrium, you know that in Newton's laws of motion you have been studied. If net force acting on the system is zero, if net force acting on the system is zero, then it is known as equilibrium position. It is your equilibrium position. So you know that F is equals to minus of your du divided by dr beta. Or else I can write this one as minus of your du divided by dx. That must be equal to how much for me? 0. Then so for equilibrium, minus of du by dr or minus of du by dx must be equal to 0. Then the body is said to be in the equilibrium condition. Clear? Sure. If you are getting u minimum, that indicates stable equilibrium. Then if you are getting u maximum after doing the differentiation, that will represents me your unstable equilibrium. Isn't it? That means that f is equals to 0. If u minimum, you are getting u minimum, that represents me the stable equilibrium. If you're getting u maximum, that represents me the stable equilibrium. I'll tell you how that one. Like say for example, if you're doing the double differentiation of this one, d square u divided by dx square. If it is greater than or equal to 0, or I can say that df by your dx is lesser than 0. That means double differentiation of your potential energy with respect to x, if it is coming out to be greater than 0, or df by your dx is lesser than of your 0. This represents me stable equilibrium. Okay. In the same way, if d square u divided by dx square is lesser than 0, or I can say that df divided by dx is greater than 0. Yeah. By default, you need to remember this one better. This will represent me what better? Unstable equilibrium. Done. This is stable equilibrium. This is your unstable equilibrium. Isn't it? If you're getting u minimum, that represents me stable equilibrium. If you're getting u maximum, that represents me your unstable equilibrium. Then better, let me give an example. First example, let's say u is equals to 2x square minus 4x plus 5. I'm asking you find position of equilibrium and also its nature. And its nature of equilibrium. There is another type of equilibrium also better, neutral equilibrium. df by dx must be equal to 0. Done? So what is my first step? We need to do better for this one. Differentiate it, calculate the force. F is equals to minus of du divided by dx. So differentiate this one. So it is d. This one is 2x square minus 4x plus 5 divided by dx. I hope you can do this differentiation. So for the first one, 2 will be out. Differentiation of x square is nothing but 2x. That means this will be equal to minus. There will be minus outside. Minus, this is 2 into 2. This will be equal to 4 into x. Minus, next one is nothing but 4. 5, differentiation of 5 is 0. So that must be equal to 0. So that will come out for me how much better? X is equals to 1. So if I'm getting x is equals to 1 greater than 0, that represents me the position of equilibrium. Isn't it? This is the position of equilibrium. At what position we are getting equilibrium is x is equals to 1. Now we need to calculate the nature. How do you calculate the nature? df divided by your dx. I told you if df by your dx is lesser than greater than 0, what will be the relation? So this is -4. So if it is -4 means what happens? Lesser than of your 0. That means it will be your stable equilibrium. How I got this 4 beta? I substitute this value of x in this one. Okay, 2 into x square. X means 1, 2 minus 4 plus 5. Okay, so x is equal to how much I'm getting right now for me? 4. Done beta? Or else you can differentiate directly f with respect to x. That's not an issue. df by dx. How much we got here? 4x minus of your x. You differentiate this one. I'm writing yes. With respect to x. So we'll get -4. So that represents me what beta? Stable equilibrium. You can even write this. Clear? First step is du by dx. So you are getting right now x is equal to 0. And make sure that that will represent the position of equilibrium. Now again you differentiate f with respect to x. If value is greater than 0, then that represents stable equilibrium. And lesser than 0, that represents the stable equilibrium. Greater than 0, unstable. Lesser than 0, stable. So here x, df by dx is -4. So that represents for me what? Stable equilibrium. Done beta? Got an idea? Good. Next one. Work energy theory. I hope you remembered it. Work done by all forces must be equal to change in kinetic energy. Work done by all forces must be equal to your change in your kinetic energy. So that means I can write here work done by all forces, maybe conservative or non-conservative, that must be equal to your half into your m into your, this will be equal to your V final square minus of V initials. This will be the work done by all forces. So work done by all forces is equal to your half into your m V final square minus of your V initial square. Done beta? Next one. Mechanical energy. Mechanical energy conservation. So what is the definition, beta? The work done by all the external forces becoming 0 and internal forces are mainly conservative in nature only, then total mechanical energy of the system will always remain for me conserved. Now remember this one. If work done by external force is 0 beta and internal forces are of conservative nature only. Of conservative nature only, then total mechanical energy. Then total mechanical energy of the system will remain constant. Done? You need not remember the statement, you can directly remember the formula. Mechanical energy is equals to sum of potential energy plus kinetic energy. This should be remaining for me constant. That means initial potential energy plus initial kinetic energy must be equal to your final potential energy plus of your final kinetic energy. Okay. So what is the mechanical energy conservation? Work done by your external force is 0 and internal forces are of conservative nature only. Then total mechanical energy of the system is remaining to be a constant. That means initial potential energy plus initial kinetic energy must be equal to your final potential energy and final kinetic energy. Then next one, power, represented by P. I hope everyone remembered it. Power is nothing but rate of doing work, W divided by T. W is equal to F dot into S divided by T. S by T is nothing but velocity, so it is F dot V. Okay. P is nothing but what beta? Rate of doing work. That means if I'm writing average power, P average will be equal to work done divided by time. I can even write P average is equals to change in kinetic energy divided by your time. Anything, energy divided by time. No? Done? So rate of doing work is called as of your power. P average is work done divided by time, or change in kinetic energy divided by time. Done, beta? Problems देख लेते हैं बेटा. First problem देख लीजिए. If the kinetic energy is increased by 300%, its momentum increases by, its momentum will increase by. We need to write the relation between kinetic energy and momentum. Kinetic energy formula is half into m into v square, beta, isn't it? And momentum is equals to m into v. So I can write here kinetic energy is equals to your p square divided by 2m. What I'm doing is I'm dividing and multiplying by mass this one. So this will become for me m square into v square. So it is your p square divided by 2m. This is the relation between kinetic energy and momentum. I hope you remember this one. That means momentum will be equal to under root of your 2m into kinetic energy. Done. So whenever you're talking about percentage beta, you always make sure that final value minus initial value by initial into 100 will give me the percentage. This is a basic formula to calculate the percentage. Isn't it? So for this one, I can write here K final minus K initial divided by K initial into 100. This is how much for me? 300%. Okay. That means this will be 100 ones are 100 threes are. So I can write here K final minus K initial is equals to 3 times of K initial. Isn't it? That means K final will be equal to 4 times of K initial. Isn't it? What is asking the problem? Its momentum will increase by how much time? So change in momentum if I'm writing. So P final minus P initial divided by P initial into 100. is equals to how much? This is the question. So can I write the momentum in terms of energy? That is under root of your 2m into your k final minus under root of your 2m into your k initial divided by under root of your 2m into your k initial into your 100. So it is equals to root m gets cancelled. So it is root of your k final minus root of your k initial divided by root of your ki into 100. So that will be equal to root of your 4 times of ki minus of root of your ki divided by root of your ki into your 100. So that will be written as of your 2 into root of your ki minus root of your ki divided by root of your ki into 100. So it is 2 times of root ki, isn't it, into 100. So that will become how much for me? 100%. Done, beta? Very good. I hope you got it, everyone. If the kinetic energy has been increased by 300%, its momentum will increase by. This is a basic method. You can directly do it by the shortcut formula also. That will do it once we clear with all the concepts. Okay? Check. Take this one more question. Try to do it faster. If the linear momentum is increased by 50%, then kinetic energy will increase by. Kinetic energy will increase by. Same formula again. Kinetic energy is equals to P square divided by 2m. So P final is how much, beta? Linear momentum is increased by 50%. यानी अपने पास we are already having P initial. It is increased by 50%. यानी 50 by 100 times of Pi. Isn't it? So that will be equal to how much for me? P final will come out for me how much, beta? This zero will get cancelled. 5 ones are 5 twos are. That means this is your P initial plus this one is 0.5 times of P initial. That is 1.5 times of your P initial. So I need to calculate percentage change in kinetic energy. That means K final minus K initial divided by K initial into 100. So that will be equal to your P final square divided by 2 times of your minus P initial square divided by 2m divided by, I can write this one as of your P initial square divided by 2m. Done, better? Anything is getting cancelled there, better? This one is into 100. Isn't it? So this 2m, this 2m, this 2m will get cancelled. P final is equals to how much for me? 1.5 times of P initial ka whole square minus P initial square divided by P initial square multiplied with your 100. That's it now. So that will be equal to how much for me? 1.5. That will be equal to your 2.25. This one is 2.25 P initial square minus P initial square divided by P initial square into 100. So this will be 1.25 times of your 100 because Pi square will get cancelled. That means this will come out for me 125. Done? Very good. Clear, beta? Done, beta. That is question. An object of mass 2 kg falls from rest to a vertical distance (10 meters) and acquires a velocity of 10 meters. The work done by the resistive force of air on the object is take G value as of here 10 meters per second. I'm giving the options. Answer is 200 joules. This one is minus 200 joules, 150 joules, and fourth one is minus 100 joules. So try to do it better. An object of mass 2 kg is falling from rest. It means from here. Mass of this one is 2 kg. Starting from rest, means U is equal to 0. The vertical distance. This vertical distance is given for me h. H is equal to how much for me? 10 meters. The weight of this body acts in the downward direction, beta, m into g. And air will be existing in the opposite direction. Air resistance is in the opposite direction. And with what velocity it strikes the ground. So V is equal to how much is given for me? 10 meters per second. Then beta. Yeah. I can apply here work energy theorem. Work done by all the forces must be equal to change in kinetic energy. That means work done by your gravity plus work done by your air resistive force must be equal to half into m into v square minus half into m into your initial square. So work done by gravity mg into h, same in the downward direction. Work done by your air resistive will be equal to your half into m into v square, because initial velocity is anyhow 0. So that will be equal to half. Mass is right now for me 2. Velocity is nothing but 10 square. This 2 will get cancelled. So this will be equal to 100. Okay. So work done due to your air resistance. Air resistance is equals to how much for me? This one is 100 minus mg into h. So that is equals to 100 minus mass is 2. G value is 10. Height is nothing but 10. So this will be your 100 minus 200. This will be equal to minus 100 joules. Fourth option. Minus 100 joules. Got it? डन बेटा, चलो और एक क्वेश्चन ट्राई करो. A particle moves in a potential region given by u is equals to 8x square minus 4x plus 400 joules. Its states of equilibrium is, its state of equilibrium will be, first one, x is equals to 25 meters, x is equals to 0.25 meters, x is equals to 0.025 meters, and fourth one is x is equals to 2.5 meters. So try करो. So what is the condition for this one, beta? I told you force must be equal to 0. Now do you calculate the force? F is equals to minus of du by dx. This is our condition. Potential energy is given as of your 8 into x square minus 4x plus of your 400. इसका du by dx कर लो. Du by your dx will be equal to, this is 16x minus of 4, isn't it? For equilibrium, I told you that minus of du by dx must be equal to 0. That means minus of 16 into your x minus 4 must be equal to 0. Done, beta? How much I'm getting? Minus 16x is equals to 4. X is equals to, so 4 by 16, 4 ones are 4 fours are. That means 1 by 4. 1 by 4 is 0.25 meters. So which option is correct right now for me? 0.25 meters. So tell me whether it is stable or unstable. I told you that if d square u by your dx square is greater than 0, that will be stable, isn't it? If d square u by your dx square is lesser than 0, that will be your unstable. Okay. Now d square u by dx square, if I do it out, it is coming out to be greater than 0, isn't it? See, d square u by dx square. U ka differentiation karo. U how much you got right now? This one. Double differentiation. So that is coming out for me 16, which is greater than 0. If it is greater than 0, it will represent for me the stable equilibrium. Done, beta? No question. A block of mass m moving with velocity v naught on a smooth horizontal surface. Smooth horizontal surface. And hits the spring of constant K as shown. The maximum compression in spring is, okay? This is a given diagram. This is a block of mass m moving with velocity v0. And there is a spring here right now. The spring constant is k. This is a situation. Options given are into your v0. Second option is under root of your m by k into v0. Third option is under root of your m divided by 2k into v0. Fourth option is m by 2k into your v0. So try come.
The second option, under root of m by k into v0.
Under root of your m by k into your v0. आ गया सभी को? Initial kinetic energy plus initial potential energy must be equal to final potential energy plus of your final kinetic energy. Initial kinetic energy कितना है? Half into m into v0 square. Initial potential energy of that one is 0. Then final kinetic energy in the spring will be equal to half into kx square and final kinetic energy is 0 because यहाँ पर आके रुक जाएगा वो basically, isn't it? ये half चले गया. Is your m into your v0 square is equals to k into your x square. That means x square is equals to your m into v0 square divided by k. तो x की वैल्यू कितनी बन जाएगी बेटा? X is equals to under root of your m by k into your v0. Second option will be the answer. आया सभी को? डन बेटा, चलो ये ट्राई करिए जल्दी से. A force F is equals to 20 plus 10y acts on a particle in the y direction. Okay, my question is, work done by this force to move particle from y is equals to 0 to y is equals to 1 meter. चलो जल्दी करके बताओ. Options are 20 joules, 50 joules, 5 joules and 25 joules. क्या constant force है ये? What type of force it is बेटा? y जैसे जैसे चेंज हो रहा है फोर्स वैसे वैसे चेंज हो रहा है ना बेटा. वेरिएबल फोर्स.
Variable force.
F is equals to 20 plus 10y is a variable force. अगर वेरिएबल फोर्स है तो वर्क डन निकालने का तरीका इंटीग्रेशन. W is equals to integral of your f into your dy because f is given as a function of y. from वहां से वहां तक 0 से 1 तक integral this is a 20 plus 10 into y into your dy. Limits are 0 to 1. ये हो गया. Integral of 20 into y. This will become for me 20y plus this will become for me 10y square divided by 2. Limits are 0 to 1. I hope you can do this one. 2 1s are 2 5s are. तो ये बन गया मेरे पास 20 into 1 plus this one is right now for me 5 into your upper limit minus lower limit. That is nothing but 1. Isn't it? So that is a 20 plus 5. That will be 25 plus. Okay. डन बेटा? इसका आंसर बताइए जल्दी से. When the bob of a simple pendulum swings, the work done by tension, the work by tension in string is, first one is greater than 0, lesser than 0, 0, maximum. चलो बताइए. जल्दी. When the bob of a simple pendulum swings, the work done by the tension in the string will be equal to how much? ये तो simple pendulum है ना बेटा ऐसा. So it will be oscillating like this. So tension in this one will be T. Weight of this body will be equal to mg in the downward direction. Displacement of this body कौन सी direction में रहेगा? इस direction में रहेगा dx. So work done will be equal to f into your dx. So it is equals to f into dx into your cos of your theta. Theta is the angle between force and displacement. तो इन दोनों के बीच में की angle कितनी है बेटा? 90 degrees every time. So w is equals to f into your dx into your cos 90. कितना हो जाएगा? cos 90 कितना बेटा? 0. Answer will be 0. Done. Very good. ठीक है. कल इस पे और थोड़े प्रॉब्लम्स करके we'll keep the full stop for this chapter. Then we'll try to enter into the next one. कल वर्क पर एनर्जी के और एनर्जी कंजर्वेशन और थोड़ा बहुत मैकेनिकल एनर्जी कंजर्वेशन की प्रॉब्लम्स कर लेंगे. ठीक है. चलो टेक केयर बेटा. बाय. हाँ बेटा.
Sir, most of the students are studying this chapter for the first time, although some of us are done with this.
क्या बोले कि?
Sir, most of the students of the first year are studying this chapter for the first time.
How come it will be the first time बेटा? आप लोग आईपी के लिए तो पढ़े ही होंगे ना?
सर वो बहुत थरो पढ़ाते हैं आईपी के लिए, तो लाइक डेप्थ में नहीं जाते कॉन्सेप्ट.
अच्छा. So what do you want me to do? Or you need to go till deep in detail?
Sir, I'm personally done with this, but the rest of the students are still like yet to go for it, like in depth.
क्या? Little bit louder.
So like majority of the students are not done with this chapter in depth, so they are suffering because of like.
Okay. तो अभी एक काम करो, आप लोग ये जितना मैंने कराया ना इसको एक बार आप गो थ्रू करिए. न्यूमेरिकल्स में हम लोग को डेप्थ कर लेते चले जाएंगे स्टार्टिंग फ्रॉम द वर्क पर एनर्जी वंस अगेन.
Sure.
ठीक है ना. तो वर्क पर एनर्जी का बेसिक जो डेफिनेशन कराया ना, ये जो इतना मैंने नोट्स करवाया था वो नोट्स को एक बार पढ़ लो सभी लोग. हम लोग कल से क्या करेंगे, वर्क पर एनर्जी का एप्लीकेशंस करते चले जाएंगे इन डिटेलली, सो दैट अगर कोई जेईई मेंस का भी बच्चा है तो जेईई मेंस के भी क्वेश्चंस और नीट के क्वेश्चंस भी कर लेते चले जाएंगे. और जहां कहीं पर भी कोई कॉन्सेप्ट में दिक्कत हो रही है तो लेट मी नो बेसिकली. ठीक है ना.
Sure, sir. Thank you.
I'll try to keep another 2 or 3 days for work for energy. That's not an issue. Okay. I was thinking that आप लोग already हो चुका है. You are doing the revision with me.
No, sir.
अच्छा. ठीक है चलो कोई प्रॉब्लम नहीं. We'll try to do in detail later. No problem.
Thank you, sir.
Bye.